Let's talk about data profiling, which in simple terms is the profiling of specific data sets according to specific data dimensions to find data quality issues. However, there's a lot going on under the hood, both in terms of how profiling works and also the purposes that it can be used for. Let's take a look at these. Data profiling, in specific, is the analysis and assessment of values and content in any dataset. It's in many cases the first step in the data quality improvement process because it's what brings the data problems to light. And then all of the other steps are about fixing them. It's also the most frequent data quality type of technique, and it's what most people associate with data quality improvement. But out of curiosity, it may be the most frequent one because you don't always follow up on it. You may always do profiling to detect problems, but you may not fix all of these problems. But anyway, here we are. There are usually 4 distinct types of profiling operations, each valuable for its own purpose. The first is data value validation. That is, given a set of rules that you have, figuring out whether the values in a database table or any dataset are reasonable or not. The second is connected to the first, and it's about discovering anomalies, also known as outliers. That is, when you know the values that fit in, you also know the values that stand out. The third is data format and model validation. It's a little bit like the reverse of the first. So in this case, you validate the data fields or the formats or the specific patterns based on the values. For example, when you have numbers in character fields, that's not a value problem, it's the actual format that is reversed. And finally, we have business rule discovery and/or validation. That is, you derive the possible business rules for the values based on the existence of these values. For example, if all names are character strings up to 128 of length, then that rule is suggested for that data field. Or you can take existing rules and you can validate them with profiling. Validation of the data values themselves is a very frequent type of profiling. In other words, you are gauging whether values in a given database column or table or any other format of data source are values as expected or whether they don't fit those patterns. Data values usually can be in compliance or not with a couple of key areas. 3 main ones. The first is complying with the type. That is, do these values match the type of the field? Do we have characters in a numeric field, for example? Or do we have dates as character strings instead of date objects, and so on? The second is domain compliance. That is, if you know the boundaries for a given field, do the values fit those boundaries or not? For example, you have a score that is supposed to be from 0 to 10, but you find out that you have values of -1. It doesn't fit the domain of acceptable values, the range. And finally, business rule compliance. So, are the values obeying specific custom rules? For example, if a customer entity requires at least one instance of a valid address for that instance of the customer, do we have any customer instances that don't have an address? In that case, the customer entity could have all values complying with the type and complying with the ranges, but they don't comply with the business rule. Out of curiosity, the data may not be in compliance with one or more of these types, possibly all 3 at once. Then we have anomaly analysis, and this is the detection of values that are significantly different from the majority of the values in that data source. It's important to note right away that this can in fact indicate an error, and in many cases, that's precisely what happens. But the outliers can also be legitimate, and they may have a reason for being different. For example, if you have an aggregate of sales numbers by month, and you have a spike in both November and December, those may be real numbers motivated by Black Friday or holiday purchases, and not errors in the aggregations. Anomaly analysis usually starts by determining a baseline of the values, or the domains of acceptable values, and it detects outliers through one of multiple ways. The first is by performing a frequency distribution and detecting the values that are in very low frequency. The profiling tool literally tells you, for example, for a number, the value 10 shows up 90% of times, the number 11 shows up 5% of times, and so on. And when you have a specific value that only shows up 1% of times or 0.5 or whatever the percentage should be, you know that it's very rare for that value to appear. So it's an outlier by definition. The second is by examining the variance, or alternatively, the standard deviation of values, and then detecting the values which are in the extremes. So it's very similar to the frequency distribution. You do a normal curve of the distribution, and you figure out which types of values are in the extremes. We'll cover this in detail later, but all of these statistical measures are usually calculated by the tool itself. So you just perform the profiling, and it spits out the results. Anomaly analysis can also usually be aided by data from other columns or tables, because this helps give context to the outlier values and tell you whether they're mistakes or not. For example, let's say that you're analyzing anomalies in a table of temperature readings for a physics project. Maybe you identify a couple of outliers, but maybe there's another table that has pressure readings, which may be related. So you can perform a join on the database table to obtain data from that table as well. So for each temperature outlier, you can check the corresponding pressure. And maybe some outlier temperatures have a higher pressure associated, so they're realistic. But maybe other outlier temperatures have no pressure associated, so these may be glitches. So what happens is that adding data from other sources can help interpret these outliers and gauge whether they're mistakes or whether they have a justification. Then we have data format and model validation. This is usually the reverse of data value validation, but uses a similar process. That is, instead of verifying that the values fit the rules, you're verifying that the rules are the right ones for these values. For example, data value validation tells you that the rule is for a set of values to be from 0 to 100. And if this particular reading is outside, it's a wrong value. But data format or model validation tells you the opposite. It looks at the values and tells you, hey, most of these appear to be outside 100. So for example, the rule of 0 to 100 is a wrong rule by itself. And usually, the same three types apply as for value validation. So first, you can validate the data types. That is, the types that are used for a given set of values may not be the right ones. In our previous example, if you have numbers in a character field, maybe it's not the values who are wrong. Maybe it's the field structure that's actually wrong for these values. Both can be true, by the way. Also, data domains. That is, the value ranges may not be the specified ones, but instead there may be different ranges not documented. And finally, you can validate data business rules. So the data present may not obey the specified rules, but they may obey the rules which are not mentioned. And these can be suggestions for overriding the current rules. For example, you may have a field for a score in terms of performance from 0 to 100, but informally this was changed to 150, but the database people did not know about it. And now you find out that most values go up to 150. So maybe the rule should be 0 to 150 instead of 0 to 100. And data profiling suggests these new rules. Additionally, data profiling can be used to actually discover new business rules or to validate these in data sets if you already have an idea of what they are. There is some degree here of overlap with data format and model validation that we just covered, but in this case, we're just focusing on the business side of the rules, not the technical side. So what is documented and defined with the business users? So for example, maybe we have no metadata for the customer class, period, but profiling shows that all customers have the phone number field filled and with a specific format. For example, 3 digits, then a space, then 4 digits, then a hyphen, then another 4 digits. So we may suggest a rule that every customer must have a valid phone number value and in the format 3 digits, space, 4 digits, hyphen, 4 digits. The data profiling tool analyzes this pattern and suggests this rule. And please notice the distinction here. Even if the data are already in this format, if this is not a formal rule in the organization, there is no obligation for the data to be in this format, nor do we have a way to enforce this format. But if you define the business rule formally in the metadata repository, you can create data governance controls to monitor and test this format. And you can formally say this is right or wrong versus just have an opinion. Usually, if there is no metadata regarding the business rules, profiling can help you start from scratch and discover new rules, which usually are present in the data but are not formal. This is an example. Maybe this is a legacy system, and maybe the people who managed it knew that this format was required, but it's not formally required. So we do a profiling of these data, and we figure out, oh, this should be a formal rule. but it isn't. So let's now make it a formal rule. On the other hand, if you already have formal business rules, you can use the profiling tool to help validate them or to even suggest changes to them. This is because applications change, people change, a lot of things change over the years. So it's very useful to do automated profiling every once in a while just to make sure that these rules are still the right ones. We can also note here that data profiling usually has two major uses. One is related to the data themselves, and the other to metadata. Or if you want to oversimplify a little bit, one of them is related to data management and the other to data governance. So first, profiling can be used to actually raise data quality issues. This is the usual scenario. So this is what you usually think of when you think of profiling. It's looking at the data and saying, hey, these data are probably wrong. We have an issue. Either because the values are outliers, or they don't follow the rules established, or many of them are missing, or any type of data quality problem in any dimension. But also, profiling can be used to enrich the metadata. That is, metadata should ideally, at least, contain information on all the business rules, all data formats, all fields, and more. But there is a chance that it may not be updated, or it may even be missing. For example, you acquire a new company and their databases, but you have no metadata. You have no idea what the data are about. So you can use profiling to find out this information. So profiling helps you discover the rules for these data, the data formats, the data examples, and other information that is useful to give context to these data, to make them understandable to everyone that needs to use them. In terms of techniques, data profiling usually leverages statistical and mathematical techniques in order to derive insights. In most cases, you don't need to know these to use the tool because it's a black box, the techniques are already within it, but having a deeper understanding of how they work can help tell you why the tool detected a specific value as being an outlier or why it's suggesting a specific rule. These techniques can include, for example, first, determining ranges. That is, are the values of this field constrained within a range? Yes or no? And if so, naturally, what is the range? Usually, it's just a matter of doing the minimum, the maximum, and then suggesting the range. It's a basic mathematical operation. Then, determining how many values are absent and missing. That is, how many values are filled in terms of this column or even the full record, and how many are empty, and what shape do they take in specific when they're empty. Is it a zero? Is it a null? Or is it another format? Then, determining what is the cardinality of values. That is, the set of how many distinct values are there. For example, if you have a column with true or false, the cardinality is 2, and so on. This helps tell you how many different values a field can take. And also, what is the frequency distribution? That is, for each distinct value, how many times does it occur? In our example, if the column is true or false, the cardinality is 2, but it can also tell you out of 100 values, 20 of them have the value true and 80 have the value false. And additionally, for numerical values, other calculations can be performed, such as the minimum and maximum values, the mean and the median, and the standard deviation. These may also be helpful. Some of these analytical techniques in specific provide interesting insights regarding the rules and the formats of data. For example, if most values or all values of a column are unused, that means that this column is not used. It's useless. Or maybe it's used for a different purpose, or it could be represented in a different way. Another example is if the cardinality of a column is 1. For example, if for a whole column the only value that you have is true, then it's useless because it only has one value. Or something else may be going on that we don't understand yet. Or for example, if a field is used for multiple purposes, it's probably an overloaded element or a composed element. That is, it contains more than one type of information in one field. For example, a field that's called price with tax, which could be split into two separate fields, one for the price and one for the tax. Some fields may have 2 or even more basic fields within them. Or another example is if all the values of a field fit a certain pattern, that should be a business rule or a constraint. For example, phone numbers are always in this specific format, then this should be a format. Or for example, if in the gender column you only have 3 values, male, female, and custom, then a business rule should be that the only 3 acceptable values are these. And it can also tell you if a field is derived from other fields, such as a full name field, which may be just appending the first name field plus a space plus the last name field. These fields can be kept or deleted, but the tool identifies they are redundant. And finally, please notice that when dealing with data that are present in multiple tables, profiling can also be useful to detect dependencies and correlations among elements in different tables. And this can be useful for multiple purposes. The first is detecting the presence or absence of either primary or foreign keys in relational databases. For example, detecting if all records in a table have a unique identifier, which is a primary key, or if it's not unique, and if all records that reference records of another table are valid with a foreign key relationship. That is, if I have a customer instance that is referring to the address with ID 17, does that record with ID 17 in the address table exist or not? So it can detect both non-existing parents and non-existing children. In our example, it can identify customers that don't have a valid address, but also addresses that are not used by any customer. Then, it can also detect dependencies and correlations among data, which can indicate a dependency relationship. For example, a customer may only have a delivery address if they have at least one purchase, indicating that the existence of one field probably determines the existence of the other one. And it can even suggest a rule, such as if there is a purchase with a given customer reference, then that customer must have at least one valid delivery address. These sound basic, but putting them formally is important, and the profiling tool helps you do exactly that. What are some examples? The first is performing automated testing. So, although data profiling is usually done in a manual manner to detect individual data quality issues, once the rules are set, you can run automated tests to monitor the current data quality. For example, once a week, once a month, and so on. Then, beware of the different meanings of anomalies. Anomalies are very important because they can occur for a myriad reasons. They may be wrong values, and that happens, but they may be exceptional situations which may make sense, such as spikes in sales, or they may even be values from other fields that are stored in this specific field because it's not used. And finally, tools usually have different functionality. Although some tools only perform data profiling, others can include data quality operations as well, such as remediation, so that both can be integrated. So a data management team can perform profiling, detect a problem, obtain authorization from their superiors, and perform remediation all in the same process and with the same software. What are our key takeaways? Data profiling analyzes and assesses data, and it has four major purposes, or sub-operations. It can validate the data, the values themselves. It can find anomalies. It can validate the data formats or patterns, that is, are the rules correct? And it can discover or validate business rules for these data. To begin with, the first operation is value analysis. Profiling performs analysis of values by reviewing whether they're valid or not, usually in three major areas. Do they fit the expected format? Do they fit the range of values or the domain? And do they fit our business rules? Then, data profiling can reveal anomalies. It detects which values don't fit the ranges, whether formal ones, such as rules, or just informal ones, such as frequency distributions. These are outliers, and they may be errors or not at all. Then, data profiling can validate the data models or formats used. That is, do the existing data fit these formats or not? Usually, it also performs analysis in terms of whether a format is correct or not, whether a data range is the right one or not, and whether specific business rules are right or not. Then, data profiling can be used to derive business rules from the values present. It suggests ranges and patterns. Or if you already have formal business rules, it can help validate these and suggest changes if it's the case. And finally, most of the data profiling methods used are numerical or statistical by nature. Frequency distributions, counts, value ranges, missing numbers, standard deviations, and possibly others. So as we see, the data profiling practice is very flexible. It allows you to both identify wrong values, wrong rules, or to discover anomalies or new business rules. among many other purposes, and it usually relies on simple statistical and mathematical models.